Hello, it's Brad here, and I'm just going to quickly walk you through the process of designing a masonry beam using the Mas software. To get started, you just want to launch the software and click on the Create New Beam button that you see here. I'm going to select that right now, wait for it to load. So by default, what you see here is nothing, basically, because we need to specify our dimensions. We're at the assemblage stage, and so I'm just going to start by entering my total beam length. You'll notice that there is a length and also a clear span. I will get into that in more detail in the actual design steps section of this website. I'm going to design this 4.4 meter long beam. I can do it as a 2 or 3 course. I'll try and make it work as a 2 course beam. So I'm going to put my height in as 390. So that's 2 full blocks plus 1 mortar joint in the middle. And at this point I have enough to actually go ahead and design it. You'll see once I have that geometry information in here, it will show up. You can change the bearing length, you can change your end conditions, but at this point I'm going to move to the load stage. You'll notice that once it's drawn here, this option will light up. So I click on loading input. I'm just going to start by adding a dead load. All of these loads are applied as UDLs across the entire length of the beam. So I'm just going to put in a length of, or a magnitude of 13 by default. It will put a 13 kilonewton per meter line load along the length of this beam. I'm going to add a live load now. Let's say this is some load coming from the roof, maybe a little bit lower, so I'm going to put 8 kilonewtons per meter. You can also have snow, wind uplift, that kind of thing. So what I'm going to do is add a snow load, and this might be a little bit higher. I'm going to put just 10 here. So now that this is entered in, as soon as you have any loads, you'll notice that this moment deflection design button will become available. So I'm going to click on that and quickly do a design, and we'll see what I come up with. So this is a very common issue that you see where the only designs that pass are the ones where the steel doesn't yield. There are different ways to go about that. I'm going to start by trying to tie my compression steel, see if that makes a difference as it goes through. By default, it ignores it if it's not adequately confined in compression for stirrups. And you'll see it actually works, but I have a lot of steel that's showing up in this beam. What might be worth doing in this case, and I haven't rehearsed this, I'm just sort of flying by the seat of my pants here. I'm going to try doing this instead of a 2-course beam as a 3-course beam. Oftentimes, when we're looking at these types of spans and these designs, what you can do is, if it's supporting more masonry, you can simply grout an additional course, change the location of your steel, and that will help. Note that the steel is still tied, so it will still need to be confined by stirrups. I'll try and make it pass without it, but I suspect that just based on the loads, you'll see I've got a 30 centimeter unit now, a 25 MPa unit, and so in this case, I'm just going to go ahead and keep this steel tied. So now that I have my design here, you'll see it's got 2 number 25s at the bottom, so a lot of steel. That might be even difficult to make it fit when we go through and look at that in a 20 centimeter unit. But if I go through and do the shear design, you'll see it will go through. If I look at my shear drawing, you'll see actually that the capacity is more than enough. We show more detailed results in here. For those of you at home who are curious, we do go through and use the simplified and the general method that's outlined in the S304. And then now that we have a successful design, I can go ahead and click on bearing design, where it will go ahead and check what's going on at the supports. Oh, and look, this one is actually not passing. So either we need to increase that bearing area. It's only using 140. If we use the entire thickness of the wall, in this case 190, you'll see that actually is enough to make it work. And then if I look at my simplified properties now as I go down, this just gives you a general summary of what's going on. So I didn't get into very much detail here. It's just a quick demo showing you the basic steps of designing a masonry beam. If you have any questions, please feel free to either keep reading on this website or contact the Canada Masonry Design Center for support.